Let's do prime numbers and composite numbers today. Prime numbers and composite numbers. What are prime numbers? Prime numbers are natural numbers that are divisible only by 1 and itself. All natural numbers start from 1, and all numbers that are natural and are divisible only by 1 and itself are called prime numbers. So let us look at numbers 1 to 10. So I have numbers 1 to 10 here. Let's look at the number 1. 1 is divisible only by 1, isn't it? 1 ones are 1. So it has only one factor. 2 is divisible by 1 and 2. 1 twos are 2. So 2 has two factors, 1 and 2. 3 is divisible by 1 and 3. Two factors again for 3. What about the number 4? It's divisible by 1, 4 and 2. 1 fours are 4, 2 twos are 4. So as you can see, the number 4 has three factors, 1, 4 and 2. Let's look at the number 5. 5 is divisible only by 1 and itself, 1 and 5. It has only two factors. 6 is divisible by 1 and 6. 1 sixes are 6, 2 threes are 6. So 6 has 4 factors. The number 7 is divisible only by 1 and itself. 1 sevens are 7. 8. 1 eights are 8. 2 fours are also 8, isn't it? So 8 has 4 factors. 9 is divisible by 1, 9 and 3. 1 nines are 9. 3 threes are 3. 10 is divisible by these numbers. 1 tens are 10. 2 fives are 10. So 10 has 4 factors. Now what are prime numbers? Prime numbers are numbers that have only two factors. That is 1 and itself. Can you see blue? The lines in blue, the arrows in blue. 2, 3, 5 and 7. These have only two factors, 1 and itself. So these numbers are called prime numbers. Now we are going to find prime numbers between 1 and 100 using a special technique. We're going to use the Sieve of Eratosthenes. The Sieve of Eratosthenes will help us find prime numbers between 1 and 100. So the first thing we need to do is write down all natural numbers between 1 and 100. Write down all natural numbers starting from 1 up to 100. Now I have struck off 1 because 1 has only one factor as we saw. Okay. Now listen carefully. Using the sieve of Eratosthenes, we are going to find all the prime numbers that are there from 1 to 100. So first step, circle the number 2 and cross out all the even numbers. Other than 2, we have circled 2. Cross out all numbers that are divisible by 2. These are the even numbers. So let's do that. 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80, 82, 84, 86, 88, 90, 92, 94, 96, 98 and 100. So this is the first step. We circle 2 and crossed out all the even numbers that are divisible by 2. So what are we doing here? We are removing all numbers which are not prime, and finally what is left will be only prime numbers. So this is the first step. We've already removed all the even numbers, so the numbers have become lesser now. Okay, so let's go on to the next step. Circle 3 and now cross out all the numbers that are divisible by 3. One is all the numbers that are in the tables of 3. Another way of finding out if a number is divisible by 3 is by adding up the digits, and if it is in the tables of 3, it is divisible by 3. So I've circled 3. I'm going to cancel out or cross out all the numbers that are in the tables of 3. Some of the numbers have already been crossed out because they were in the tables of 2 also. So let's start. 3 ones are 3, which we have circled. Now we're going to cross out. 3 twos are 6, is already crossed out. Can you see after 5? It's crossed out. 3 threes are 9. 3 fours are 12 is crossed out. 3 fives are 15 in the second row. 3 6 are 18 in the second row has been cancelled. 3 sevens are 21 in the third row. 3 eights are 24 cancelled. 3 nines are 27. 3 tens are 30 crossed out. 3 elevens are 33. 3 12s are 36 already crossed out. 3 13s are 39. Okay, now there are some numbers left, and if you're not sure of the tables of 3 beyond 3 13s, all you have to do is add up the digits. So let's go to row number 5 starting with 41. Okay, add up the digits. 4 plus 1 is 5. It's not in the tables of 3. 43. 4 plus 3 is 7. It's not in the tables of 3. 45. 4 plus 5 is 9. 9 is in the tables of 3. So cross out 45. 47. 4 plus 7 is 11. It's not in the tables of 3. Leave it. Next number that is there is 49. 4 plus 9 is 13. It's not in the tables of 3. So leave it. Go to the next row. 51. 5 plus 1 is 6, and 6 is there in the tables of 3. That means 51 is divisible by 3. So cross out 51. The next number is 53. 5 plus 3 is 8. It's not in the tables of 3. Leave it. Next number is 55. 5 plus 5, 10. Not in the tables of 3. The next number, 5 plus 7, 12. It is there in the tables of 3. That means 57 is divisible by 3. Cross it out. Next number, 59. 5 plus 9 is 14. It's not in the tables of 3. Let's go to the next row. 61. 6 plus 1 is 7. Not in the tables of 3. Next number, 63. 6 plus 3 is 9. 9 is in the tables of 3. So cross out 63. Next number, 65. 6 plus 5 is 11. Not in the tables of 3. Next number, 6 plus 7 is 13. Not in the tables of 3. Next number, 69. 6 plus 9 is 15. And 15 is there in the tables of 3. So cross out 69. Next row, 71. 7 plus 1 is 8. Not in the tables of 3. Next number, 73. 7 plus 3 is 10. Not in the tables of 3. Next number, 75. 7 plus 5 is 12. And 12 is there in the tables of 3. So cross out 75. Next number is 77. 7 plus 7 is 14. It's not in the tables of 3. Next number is 79. 7 plus 9 is 16. It's not in the tables of 3. Next row, 81. 8 plus 1 is 9. Yes, 9 is in the tables of 3. So cross out 81. Next number is 83. 8 plus 3 is 11. Not in the tables of 3. Next number is 85. 8 plus 5 is 13. Not in the tables of 3. Next number 87. 8 plus 7 is 15. And 15 is there in the tables of 3. So cross out 87. The next number in that row is 89. 8 plus 9 is 17. Not in the tables of 3. Let's go to the last row. 91. 9 plus 1 is 10. 10 is not in the tables of 3. The next number is 93. 9 plus 3 is 12 and 12 is there in the tables of 3. So let's cross it out. 95. 9 plus 5 is 14. It's not in the tables of 3. Next number 97. 9 plus 7 is 16. Not in the tables of 3. Next one 99. 9 plus 9 is 18, which is there in the tables of 3. So let's cross out 99. Okay, so what have we done so far? First we circled 2 and crossed out all the numbers in the tables of 2. Then we circled 3 and crossed out all the numbers in the tables of 3. Now, can you see there are only few numbers left? And some of these are prime numbers. So what are we trying to do? We are trying to get only the prime numbers. So at the end, when you finish out all the crossing out, what is left will be prime numbers. So we finished with 2, we finished with 3. Let's go on to the next number 5. So circle 5. Now cross out all the numbers in the tables of 5. That's easy, isn't it? You know the tables of 5. So 5 2s are 10, already crossed out. 5 3s are 15, crossed out. 5 4s are 20, after 19, crossed out. 5 5s are 25. Let's cross out 25. Okay, let's cross out all the numbers in that row. 25, then 35. 45 is crossed out. 55, 65, 75 is crossed out. 85, 95. Can you see there are only few numbers left? All the numbers that are in the tables of 5 we have crossed out. Very few numbers left. Okay, now the only number left in the top row, topmost row is 7. So let's circle 7. And we are going to cross out all the numbers that are there in the tables of 7. So let's say our tables of 7. 7 ones are 7, we have circled. 7 twos are 14. Is it there? No. Crossed out. 7 threes are 21. Crossed out. 7 fours are 28. Crossed out. 7 fives are 35. Crossed out. 7 6 are 42. Crossed out. 7 sevens are 49. 49 is still there. Let's cross it out. 49. Okay. 7 eights are 56. Crossed out. 7 nines are 63. Crossed out. 7 tens are 70. Crossed out. 7 elevens are 77. It's still there. Let's cross it out. Okay. 7 twelves are 84. Crossed out. 7 13s are 91. Let's cross it out. Okay. So now we have a few numbers left and these are the prime numbers. Okay. Can you see we've crossed out all the numbers that are in the tables of 2, 3, 5 and 7. Whatever numbers are now left are the prime numbers. So this is the sieve of Eratosthenes where we remove all numbers and what is left behind is only prime numbers. So let's see what the prime numbers are. 2, 3, 5, 7 in the first row. Second row 11, 13, 17, 19. Next row 23, 29. Next row, 31, 37. Next, 41, 43, 47. Next row, 53, 59. Next row, 61, 67. Next, 71, 73, 79. The next row, 83, 89, and the last row, 97. So all the numbers that we have circled are the prime numbers. So did you see how we used the sieve of Eratosthenes? We wrote all natural numbers from 1 to 100, and slowly we started removing all the numbers which are not prime numbers. And what is left behind are the prime numbers. So can you see that? These are all the prime numbers between 1 and 100. Numbers which have more than two factors are called composite numbers. So right now we saw prime numbers because they have only two factors. What if they have more than two factors? They're called composite numbers. So if they're not prime numbers, they're composite numbers. Let's see some examples. 4. What are the numbers that give you 4? 1 fours are 4, 2 twos are 4. So 4 has 3 factors, more than 2 factors, so it's a composite number. 6. 1 sixes are 6, 2 threes are 6. 6 has 4 factors. The number 8, let's see. 1 eights are 8, 2 fours are 8. More than 2 factors, so it's a composite number. 9. 1 nines are 9, 3 threes are 9. 3 factors, it's a composite number. 10. 1 tens are 10, 2 fives are 10. So can you see these numbers 4, 6, 8, 9 and 10 have more than 2 factors. So numbers which have more than 2 factors are called composite numbers. What about the number 1? It has only one factor. 1 ones are 1, isn't it? So it is neither prime nor composite. It is a unique number. Let's hear some fun facts. Every prime number is greater than 1. Which is the smallest prime number? 2. The smallest prime number is 2. And 2 is the only even prime number. All the other even numbers are composite numbers. Between 1 and 100, there are 25 prime numbers. We use a sieve of Eratosthenes and we found out that there are 25 prime numbers between 1 and 100. The number 1 has only one factor, which is 1 itself. Thus, 1 is not considered a prime number. 2 and 3 are the only consecutive prime numbers. That means prime numbers that come one after the other. 2, 3, they come one after the other. None of the other prime numbers come one after the other. Twin prime numbers. What are twin prime numbers? Is the pair of prime numbers that differ by 2. That is, if you minus them, the answer will be 2. Examples. 5 and 7 are prime numbers. 7 minus 5 is 2. So it's called twin prime. When you minus, if the answer is 2, they are called twin prime. 11 and 13 are prime numbers. 13 minus 11 is 2. 17 and 19 are prime numbers. 19 minus 17 is 2. So you have prime numbers that differ by 2 called twin primes. Every even number that is greater than 2 is a composite number. And the smallest composite number is 4. So I hope you have understood, children. Thank you.